If you think about it, nearly every animal in the modern day is either eaten by another animal, eats another animal, or both.
Both prey and predator rely on sensory cues as they interact with their environment.
It was only really in the last decade or so that we realized that animals in the terrestrial environment can actually detect static electricity. We focused on caterpillars, which are an excellent example of a prey animal, and the wasps that predate upon them. We worked on 3 different species of caterpillar, and we designed a series of different behavioral experiments unique to each species of caterpillar. And with this, we would basically expose the caterpillars to an electric field that mimics the one that we predicted would exist as a wasp approaches a caterpillar in nature. And the really exciting thing we saw was that actually, yes, when a caterpillar is exposed only to these predator mimicking electric fields, they will respond defensively. The next thing that we wanted to unravel was actually how they're detecting these electric fields. Caterpillars are often very, very hairy. If you think about when you rub a balloon on your hair and it charges your hair up in the balloon, you can then move your hair around with that balloon without the two even making contact. And that's because of the electric field between the two caused by the static electricity.
So a similar principle could apply to the hairs of a caterpillar.
If a charged wasp approaches the caterpillar, the electric field emanating from that wasp could actually move the hairs. It could electrostatically deflect the hairs on the caterpillar, which may then be detectable by the caterpillar. So the charges within the hair are being separated by the electric field of the wasp. So every time the wasp flaps its wings, the hair goes out, comes back, goes out, comes back. The ecological consequence of this is that actually caterpillars themselves don't need to carry any electrostatic charge themselves to be sensitive to the static charges of their predators. So we actually saw that in all of these species that really just exposing them to an electric field alone was enough to either initiate defensive behaviors or significantly elongate their defensive behaviors. So I think the strength of the effect was certainly surprising, but also worrying.
The increasing amount of electricity found in our environment also has an effect on a prey's ability to avoid detection.
There's a real possibility that these electric fields that we are producing may be messing with the senses of animals, including these caterpillars. It may make them much worse at detecting their predators.